Hi, in this video, I'll be solving this problem, which comes from the Differential Equations and Linear Algebra book by Edwards, Penny, and Calvis. It relates to Torricelli's law, and it says a hemispherical bowl has top radius 4 feet, and at time t equals 0 is full of water. At 1 p.m., a circular hole of unknown radius r is opened. And at 1:30 p.m., the depth of the water in the tank is 2 feet. Use Torricelli's law in the form dV dt is equal to negative 0.6 pi r squared times square root of 2gy to determine when the tank will be empty. And what is the radius of the bottom hole? Okay, the hole, obviously, it has to be in the bottom, otherwise it won't, the tank won't empty out. So let's draw a diagram. We have a hemispherical bowl, and it has a hole in the bottom, and water flows out of it. The bowl has a top radius of 4 feet, so that distance is 4. This distance also 4. And at some arbitrary point in time, then the water is down to this spot. The depth of water, which is how deep the water itself is y. And that makes the rest of the distance here 4 minus y. The rate of flow of the water obviously depends on the radius of the hole. If the hole is huge, then water comes out really fast, and if the hole is smaller, it doesn't come out as fast. And in this case, we're not given the size of the hole. We're not given the radius of the hole. But in part B, we're asked to find that radius. Let's figure out some basics first. Let's summarize this. So first of all, in terms of units, the units in this problem is given in terms of feet and second. And that's going to be because this g here that's given in the problem is the usual g in physics. That's the gravitational acceleration. So is g is equal to 32 feet per second squared. We're given that at the beginning, it is full of water. If the container is full of water, then that means the depth of it is the entire depth of the bowl. So at time 0, y of 0 is equal to all of 4 feet. Whereas at 1:30, the depth of the water in the tank is 2. So y at 30 minutes is 2. Well, we decided that we're going to use second as the unit of time because that gets us the g of 32. So we're not going to say 30 here, but we're going to say 1800. That's 1800 seconds. And then we're given the equation dV dt is equal to negative 0.6 pi r squared square root of 2gy. That gets us everything we need, I think. And I call this equation star. In equation star, the unknown on the right side is y, the depth of the water, but the unknown on the left side is v, the volume of water. So we want to convert them both into the same thing. And I'm going to convert them both into terms of y. So I'm going to leave this as is, and I'm going to change dV dt into something involving dy. Well, if you actually go out and look for the formula of a spherical cap, it's complicated. And in fact, most of us don't know that formula. So let's do it a different way. Instead of looking for v, I'm going to look for actual dv. dv is a small change in v. And I'm going to figure it out using the same techniques that were taught in calculus, the disk or washer method of finding the volume of a solid revolution. If you look at the water separately, then you have a depth of y, and it's a spherical cap like that. Well, what is a small change in v? Well, a small change in v is a tiny little piece here. So this whole volume is v, and this tiny little piece is dV. That tiny little piece is a washer or a disk. Right? So dV is a volume of a small disk, and therefore it's base area times height. Well, this height right here, tiny little change, is a tiny little change in the depth of the water. It's a tiny little change in Y. Whereas the base area is pi r squared. Now let's compare these two diagrams and see what capital R is. If you go up all the way to the center, then capital R is one leg of a right triangle with a hypotenuse of 4 and the other leg of 4 minus y. And therefore, I have R squared is equal to the hypotenuse squared minus the other leg. Expand this out. And therefore, I have my dV. If I want to apply this in the star equation, then I need dV dt. Going back to equation star again, that means dV dt is supposed to be equal to all of that. So that means this is equal to all of that. I can cancel the pi's, both sides. And now what I have is a separable equation. I can separate out all the y's on one side and the t on the other side. There's only one factor of t, that's dt, so I multiply it to the right. And then I can divide both sides by square root of y over here. If I plug in g is equal to 32, then 2g is equal to 64, and the square root of 64 is equal to 8. So on the right, I have 8 times 0.6 minus 4.8 r squared dt. And on the left, I simplify the division by square root of y. And now I can integrate both sides. Right, that's the whole point of a separable equation. I separate out all the y's on one side, all the t's on the other side, so I can integrate. Remember, r squared, r is a constant. It doesn't change with t. It's a hole that's in the bottom of the container. It's just a constant, so the integral of r squared is just r squared t. All right. I have my implicit solution. Let's clean it up a little bit. Now I'm going to go back and look at the initial conditions. I have two initial conditions. I have y of 0 is equal to 4, and I have y of 1800 equals 2. And that's great, because in my implicit solution here, I have two constants I need to figure out. I need to figure out the constant c, and I need to figure out the constant r. Two constant figure out, two conditions I'm given, works out just fine. So let's use the first one. The first one is that y of 0 is equal to 4. I plug that in. I got 16 over 3 of 2 cubed minus 2/5 of 2 to the 5th. And plug in t equals 0. All this is equal to 0. Just c. So if we work out the algebra here, the arithmetic here, this is 8, this is 32. So I've worked it out. I have c is equal to 448 over 15. Plug in c. Now I have my other condition. I plug that in. And I work all of this out. I end up with R squared. It's about 0.00197, etc. I take the square of both sides. Then R is 0.04442 square feet, which is about 0.53 inches. And that would be the answer to part B. Now part A asks, determine when the tank will be empty. Let's go back and take a look at the diagram again. The distance y is the depth of the water. So when the water is completely empty, then there's no depth to the water, y is equal to 0. So I go back to my solution, which is here. And I plug in y equals 0. I plug in y equals 0, then the entire left side is equal to 0. And R squared, which I have, is that big long number, t, plus 448 over 15. Now it's just an algebraic equation. I solve for t. And I get about 3158 seconds. So those are my solutions. This is my part A and this is my part B. All right, hope that helps. Any questions, leave in the comments section below. Like, share, and subscribe for more contents. And thanks for watching. Bye.